So with today, we're just going to be able to, like, can we state the three primary trig ratios? I don't actually know if you guys would have seen tangent in grade 9. Probably just sine and cos, but I could be wrong. But then you're going to become familiar with SOHCAHTOA. Have we ever seen this before? Oh, brand new. Okay, good. Okay. State the three primary trig ratios. Label triangles and solve for missing information. Apply the Pythagorean theorem. I think you've seen that. Maybe that's the extent of your trigonometry, is the Pythagorean theorem. Okay. And then you're going to apply the three primary trig ratios. So basically what we're going to do today, here's your 2 lessons for today in the morning. We're going to do this one. It's going to teach you how to use the ratios. And then lesson 6.3 is just word problems applying these ratios. Okay. So you read a word problem, draw me a picture, and then solve the triangle is basically the gist of what we're doing today. Okay, get ready.
I want to see if I remember correctly, we didn't do like much sine or like trig at all in grade 9. Like
Again, it probably comes down to when you took math too, right? Like.
I took it first semester, I don't remember.
Okay, maybe you guys would have seen Pythagorean theorem.
Yeah.
That might be my bad. Like, I don't actually know the extent of the trig. I've never taught grade 9, so I don't know the extent of the trigonometry you do. So maybe this is completely brand new for you. This is the stuff that gets used. Like, remember when I could show you something I did on the weekend last weekend, where I legitimately drew this on the wall, and then I like worked in my shop and I figured something out using trigonometry. Okay, it's just the angle. I can show you. Okay. I'm just going to do attendance here before Ruth calls. Who's away? Anybody? Or is it just a normal 3? Alex. Abby. Alright, that's it. Okay. So here's what I got. Okay, so this is brand new. So I'll go a little bit slow. I thought maybe some of you had seen it, but again, it's not the end of the world. Like it's not bad actually. So here's what we got. We got these triangles, right? Like what we saw yesterday. Except we're not relying on having 2 triangles to use similarity here. We're gonna have a tool to like actually solve any triangle. Okay. So here's what we got. We've got this triangle ABC on the left. Okay. And what we want to do is we have like what you're going to see here. Oops, I'm on highlighter. You're going to have like an angle of reference, okay? It's going to be a Greek letter of some sort, okay? So it's like a variable, but a Greek letter, and they stand for variables. So you could see any number of these. You could see what we call theta. You could see its counterpart phi. You could see beta. Or you could see alpha. There's a whole bunch of these, but these are predominantly the ones you'll see, or at least the ones that I use. Okay. Yes?
Why not just like variables? Like, why does it have to be
Because you're going to find that variables like x, y, and z kind of typically stand for the side lengths. You might see a couple like questions where they say solve for x and it's an angle, but typically these are the ones that you're going to see as angles.
Wait, is alpha 0x, or is it? It looks like it's 0x, or is it?
Oh no, that's just how it looks. It looks like for me, it's like a sideways. It's like one of those fish, like the Jesus fish, like this guy. Alpha. Is that? Yeah, that's right. Right.
You call it Jesus fish?
That's what it is, isn't it?
Fish?
People have those on their cars. These things, right? It's a thing. You can Google it. It's a thing. They like put it on the back of their cars. It's like they call it a Jesus fish. Jesus fish. If you look it up. Huh?
Fish or fist?
Does that look like a fist to you?
No.
No, it's a fish. Fish. I'm having a hard time this morning. Fish. You can look it up. It's a thing.
That could be a fish.
That's what I'm.
The arms and the arms are-
Okay, it's a fish. Yeah, see?
It is, these were really-
That's what I'm saying. Okay, it's a real thing. Let's move on now. I teach you real things. I don't lie. That you are aware of.
Just not that.
Okay, here's the deal. Okay, so we have this thing called SOHCAHTOA, okay? You all know what the hypotenuse of a triangle is. Right? What's the hypotenuse by definition?
The longest side.
The longest side. Okay, so we know what that one is, always. And what's true about the hypotenuse relative to the 90-degree? It's always opposite of the 90-degree. Okay, so let's have a go at spelling hypotenuse. I think that's it. Okay.
No, I think you got it wrong.
Justice was shaking her head.
No, yeah.
It says it right under. You could-
Yeah, no, you meant
You
you.
wrote N-E-U, just N-U.
I'm not even
Yeah.
sure if that's right. No, it's probably right.
Yeah, yours looks too odd.
It's too long. There we go. Okay, so there's a hypotenuse. That's always the case, always. Okay. Hypotenuse is always opposite of the 90-degree angle. It's the biggest side length. It goes opposite the biggest angle. That's how it works. Okay. Then you have, we're going to reference back to our angle here, theta. Okay. We're going to like basically stand at theta. That's where we're standing. And we're going to look directly what we call opposite from us. This is what we're going to call opposite. Okay? And if I'm still standing at theta, I'm standing here, I'm going to use this other word for, like, that's another word for beside. Does anybody know what the word I'm looking for? Adjacent. Okay, so I'm going to use the word beside goes to adjacent. So I'm standing here at the x, and the side length that's basically beside me is what we're going to call the adjacent side. Okay? Do we have any like major issues? Okay, so if I go down to the box here, here's what's going to happen. It wants me to write ratios. What's the word ratio mean? What's another word for a ratio?
Another word.
Mm-hmm. A fraction. Okay, a ratio. Remember yesterday we set up a ratio with the similar triangles. There were two fractions. They're just fractions. Okay, so here's you're gonna write a fraction that represents a ratio for triangle 1. So here's what's gonna happen. I'm writing a lot of things down here. I want you to write this down because this is like important. It's the memory trick, okay? What it tells you is when the question asks for like sine, it's always opposite over hypotenuse. When the question asks for cosine, it's always adjacent over hypotenuse. And when it asks for tangent, it's always opposite over adjacent. Okay, these are all new terms for you maybe. So we'll do some questions and hopefully it'll stick by the end, okay?
Can you say the middle one again?
Adjacent over hypotenuse, so it's cosine. So we come down here, these are just the words. So sine, cos, tangent. They're equal to opposite over hypotenuse, that's the so. Right? Cosine is the SOHCAHTOA is how we say it. It's the ka portion of that statement, or that memorization tool, okay? And the last one is TOA. Okay, so the opposite and adjacent go with tangent. Okay, so we're just going to write a ratio now using the side lengths that I see on triangle 1. We've already done the hard work in labeling what each of them are. Right, so I'm going to go here. Opposite, I'm going to shrink this down. This is driving me nuts here. Opposite's going to be the red. Anywhere you see the red where I wrote opposite in red, right? That's the side length that we're going to write. If I see the blue, that's going to be the adjacent. Okay, and then hypotenuse will make, can't highlight in black, I don't think. We can try. There we go. Okay, there we see where those are going to come from. Just purely based on just looking at all of this here. Okay, so I'm going to fill out the right half of this table using the triangle that I've drawn in the top left. Okay, and remember, these things are just going to be fractions. So sine, or so, is telling me that I have to write opposite over hypotenuse. Right, so in this box, I'm going to write sine theta is equal to, what's opposite? If I wrote the side length opposites on as a side length, it's going to be AB over hypotenuse, which is going to be CA. Can everybody see what I did there? Under normal, so this is just a very general statement, okay? These are just going to be general trig ratios. When we go through these, like particular questions, it becomes a little bit easier because you're just going to assign numbers to each of those side lengths, and then you find the division or the ratio of those two numbers. Yeah, Ebro.
Does it matter if you write BA instead of AB?
No, I'm not too picky on that. I'm not too picky on that. Yeah, right.
Can you put like a line on top to indicate that's the line?
I'm going to say yes because we're going to do this more specifically in unit 2.1. We're going to discuss more specifics around lines and line segments, so I'm going to just get you in the habit of writing the line on top, okay? It's a line segment, so we're going to write a line segment on there in preparation of what I'm going to teach you in unit 2 at the end of this, okay? That's just a little formality thing. Okay? Or side length, okay? Now, let's try the next one. I'm going to write cosine theta is going to equal the adjacent side, so we're going to say BC, over the hypotenuse, which is going to be CA, or AC. Where you see where that stuff came from? Yeah, these are just where I've drawn I don't know if I did just do an adjacent. Is the color coding helping everybody or no? Okay, we got one more to do, tangent. Tan theta is going to be AB over adjacent, which is going to be BC. Okay? The reason why all three of these exist is in the real world, we're going to be given different pieces of information. So then you can use a different trig ratio to solve the exact same problem based on the information that you're able to find out in the real world. That's why all three of them exist, because they will all give you the same answer for a particular thing that you're looking for. In this case, the thing that we are looking for is, I'm going to use green, we're looking for theta, or the angle that's created in there. That's what we're looking for. All three of those ratios will give you theta, the same theta. Okay? Is everybody okay? So the next question, this is like half of a grade 11 question. So if you can do this, you could do the grade 11, half of the grade 11 question. Because we asked this in the grade 11 course. All it wants you to do is do what we just did above, but this time we have numbers instead of just side lengths, okay? So you can actually like solve this if you wanted to, but that's not what this one's doing. We'll do the solving on the next page, okay, on the back. So all it wants you to do is write sine theta is equal to something. It wants you to write cosine theta is equal to something. And tan theta is equal to something. Now when I do this, I don't always now. If I was you, I would write SOHCAHTOA somewhere. Okay? And if I ask you to state the three primary trig ratios, you'd go, okay, well, sine theta is O over H. Cosine theta is A over H. And tangent is O over A. Those are all opposite and hypotenuse, adjacent and hypotenuse, and opposite and adjacent. Is anybody like completely out, like swimming in the deep end with no water wings? Are we sinking? Are we okay? Okay. Now, this would be, I would say, like step one. I would write this out always. And step two for me would be, especially if I was doing this for the first time, is to go mark yourself at the angle of interest. That's what we're trying to find, is theta in all three of these. You're going to stand at theta, and you're going to like look across from you. When I look across from here, this is opposite. It's opposite of where I'm standing. I know that if I'm standing at the x, the side length that is beside me is what we're calling adjacent, because it's beside me. And I know, always, this requires absolutely zero thinking. The long one is always the hypotenuse. Always. Okay? So now you can just plug each of those numbers in and we're done, because it didn't ask you to solve for theta. It just said write the primary trig ratios. Okay, so what are we going to fill in? Opposite is 3 and hypotenuse is 5. Then I'm going to go adjacent over hypotenuse is going to be 4 over 5. And then tangent's going to be opposite over adjacent, 3 over 4. Okay? Those are the ratios. Remember what ratios are. Ratios are fractions. If it just says state the primary ratios, state the primary fractions is basically what it's saying. Okay? And then it's over. There's 1 mark, 2 mark, 3 marks. Are we okay? So, now comes the fun part. We actually get answers. But we still need to do this. This does not change. Okay, we're like, these I'm providing you the, I've used this word before, the scaffolding, right? The scaffolding around a building in order to build it up, sort of thing. Like that's what we're doing. Okay, I'm giving you the skills to work towards the backside of this page. So we're going to still do the same thing here. That's why we're doing it this way. Okay. So I'm going to introduce one other thing. Well, you guys already know it. A squared plus b squared equals c squared. Okay. Why don't we do that off the top? Because that's something you're already familiar with. Okay. I need to find y, right? Like y is what we're going to call the hypotenuse. And the hypotenuse in your Pythagorean theorem is c squared. Okay, so we could in theory rewrite this as xyz, but we kind of understand what's going on. So we're going to use that Pythagorean theorem there to solve for y right off the top. Okay, so c squared, well, we could write y squared. Y squared is equal to a squared plus b squared. Doesn't matter which one's which. Doesn't matter which one's which. You could say this one's a and this one's b, or you could flip it. Doesn't matter. The important one is that this, the longest one, is c. Always. Always, 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 always c. Always. The long one. Always. If you don't make it the long one always, you'll get the wrong answers. It always has to be c, the long one. Okay? So, we're going to get y squared is equal to 8 squared plus 5 squared. And we just do the math. Now, y squared is equal to 64 plus 25. Y squared is equal to, what's 64 plus 25?
89.
So y equals the square root of 89. Now, before anybody yells at me, what are you going to yell at me for, is my question. I'm almost a little bit concerned if somebody doesn't yell at me. But Mr. Mackay, what about the plus minus? Why is it irrelevant?
Can't have a negative side.
Thank you. Okay, you cannot have a negative side length. It doesn't mean that the negative doesn't satisfy that mathematical equation. It simply means that you can't have a negative side length.
Isn't it the same as when we got like two answers, like a negative time and then?
A negative time does not make sense, so you ignore it. A negative side length does not make any sense, so you ignore it. It does not mean that that negative value does not satisfy the equation and is a solution. Just doesn't mean anything in the context of our question. I'm going to say with all of trigonometry, you're solving for side lengths, you do not need that negative or the plus minus. That is the fundamental difference between your quadratic stuff and what we're doing right now. Okay? That's why I was concerned that nobody said, what about the plus or minus? It's a little bit scary, because you just wrote a test on that. Okay? You don't need to worry about that with this. Just putting that out there. Okay, so you can just give me a number. What's y equal to? 9.43 centimeters. Don't forget your units. Oh my goodness. Struggling today. There you go. Okay, now are we done? I'm going to teach you 3 things in one triangle, and it's going to be great, and you're going to use all 3 always. This is one question, I'll give you 1 skill, or 3 skills in one question. Now, what do you want to solve for here? You want to solve for x or z in terms of the angle?
Can we do either?
Yeah, I'm just asking.
Oh.
I'm just asking, which one do you want to do?
X.
Okay, we'll do x. So, that means x is our angle of reference. So you're going to put a little x there and pretend you're standing there. And then you're going to mark up the triangle accordingly. Do that.
Wait, you said put an X there?
Yeah, just put a little, no, I just mean like x marks the spot, like you're standing there sort of thing. You know what I mean? Like what I showed you up top. I'm standing right here, is what I'm saying, at that angle. So if I look directly across from me, I see the side length that's opposite of me, right? Like that'd be like me, I'm looking at Lucas, Lucas is opposite of me, but Aiden is adjacent. He's beside me. That make sense? So if I'm standing at the X, then this must be adjacent, right? And I always do this. I always label the triangle so that I have it there and I don't make any mistakes. And Y must be the hypotenuse. So if I want to solve for X, what am I going to use? Remember, recall this. You're going over top of each of these. And you're just recalling, okay, what do I know? What are the two numbers that I know here? I know opposite and I know adjacent, right? I have two numbers. Actually, in theory, you could use any of these, but because we found the hypotenuse. But you're looking at the numbers, anywhere that you have numbers to plug into these things. That's what you're looking for. So let's go over top of them. Let's pretend we didn't solve for the hypotenuse for a second. I'll explain that in a minute. Okay? You always want to use the information that's given to you in the question. Especially if you have to round, but what if I made a mistake here and now I use that number? I'm going to get the wrong answer next. So if at all possible, avoid using things that you've solved for if there's enough information in your question given to you. Just in the event that you've made a mistake calculating the hypotenuse. Right?
And not only that, just using 8 and 5 would be easier than having to plug in 9.
Yeah. Having to you just want to do what's easiest and that's going to guarantee you results, right? I'm pretty confident that that answer's right, but it could be wrong, but we also rounded it. You know what I mean? Which means the next answer is going to be wrong, which means the next answer is going to be wrong. Just not wrong, but just a little bit off. If you do 40 step, like say you're building a building and you've used that number 40 times, that rounding error just adds up. The more times you use it. You know what I mean? If you can avoid using it from the beginning, you don't have any rounding error. That's why we use things like fractions, so that we don't round ever. Okay? So let's look at this is the thing you're always going to write. So let's go over top of them and look at what the two pieces of information I have. I have opposite and adjacent. Does sine have opposite and adjacent in it? No, so I'm not going to use that one. Let's go to the next one. Adjacent and hypotenuse. Nope. Let's go to the next one. I know opposite and I know adjacent. I see opposite and adjacent. That looks like the one I'm going to pick. Right? So I'm going to go, okay, that's fine. Tan x is going to equal opposite over adjacent, which is going to equal 8 over 5. Okay? Nothing new to this point. Now, the next thing I want you to do, give me a decimal for 8 over 5, please. What is 8 divided by 5?
1.6.
Okay, perfect. Is there more decimals there, Justice?
No.
Okay. Okay. We are now as far as you can get that I've shown you. Now, here's the cool part. Here's what I love about this little piece of paper I gave you. It's kind of cool, actually. And when I saw this for the first time, I went, this is much better to show it to you this way than the calculator. So I want everybody to go look at their table for a sec. For your purposes, in grade 10 academic math, you are never going to use these guys here. So you do not need them right now. So this whole last 3 columns you're not going to use, okay? Ever. Now, I do see another column. And sorry, this is a bit blurry, but you guys have a nice clean version. I see a tangent column. And then underneath that tangent column, I see a bunch of decimals. Here's what you're going to do. you're gonna go find the decimal that we just found up here. 1.6. Underneath the tangent column, because it's tangent that we're using, go find 1.6 on the table. Once you find it, let me know. And where is it exactly? Is it at 69? Oh, one sec. Don't get too carried away here. One sec.
Oh, it's 2 6. 1 6 is at 58.
Okay. You'll notice it's in the second portion of the table, right? We're going to go all the way down to 1.6. It's right here. I found the decimal. Here's my job. Read directly across to the angle that corresponds with it. What angle is it? 58. That must mean that x, angle x, is equal to 58 degrees.
What about the other one?
The what?
What about the other one?
Yeah, we'll do that now. We'll do that now. Yeah. I give you 3 tools to deal with triangles here. 3 tools with 1 question. Okay? There's one other thing that you should know. What do the angles in a triangle have to add up to? The interior angles have to add to one number always for all triangles. What is it? It's 180 degrees. They always have to add to 180 degrees if it's a triangle. So I can use that fact. I could say, okay, well, angle Z, angle Z must be equal to 180 total minus the 90 from the corner minus the angle I just found. So you can do the math on that. Angle Z should be equal to what? (32 degrees). Don't forget your little degree there. If I say solve this triangle, this is what you're doing. You're solving for all, like, you should be able to write on that triangle all 3 side lengths, all 3 angles should be filled in. That's what it means to solve a triangle.
Is it a 7 or a Z?
A Z. I put the sticks through the Z's. Any issues? But the table is quite fascinating to me. I don't understand how we're able to compact all of the triangle's answers onto one piece of paper. It's like a little bit fascinating, actually. You could insert any 2 side lengths. It's going to spit out the numbers. It's quite perplexing. Doesn't matter what the side lengths are. You plug them into that and you get a ratio. That ratio is on that table somewhere. I find that amazing. Okay, let's do the last one. Look how much time we got. Okay, let's do the last one. Okay, your homework for this isn't the piece at the bottom. You guys can do the textbook questions that are up on the board there, okay? Besides 6.2. Okay? Now, let's do this one. This is a good question. Can you use Pythagorean theorem here? Not yet. Good. Not yet. Still doesn't change the fact that I need to solve for the side lengths. Okay. You can tell me what angle Z is, though. What's angle Z? Angle Z. Well, no. Sorry. Y. Sorry. Angle Y, sorry. Angle Y is equal to the 180 degrees that they all must add to, minus the 90, minus the 38. So angle Y must be what? Okay, that's a start. We can fill that in now. Just keep in mind, that's a found number. Okay, it's 52 degrees. Now, I'm kind of stuck now because I don't have another tool based on what I've shown you. Like, I can't use Pythagorean theorem to solve for the side length because I don't have two side lengths. I'm missing two of them. But I can manipulate what I showed you up top to solve for something else. Okay, so I'm gonna, let's just pretend we're standing here at the 38 degrees. Okay, what's opposite of me? Z is opposite. That must make X adjacent. And then the 20 must be the hypotenuse, right? As you can see how if I do this every single time I do a triangle like this, I might not necessarily write it down anymore because I've done this enough times that I'm visually in my head I can see each of them, but you're going to want to write these down if you can't visualize it. You just get in the habit, right? You know which one's opposite, which one's adjacent, and you plug the stuff in, you know? So, again, we're going to write SOHCAHTOA at the top. And I'm going to take a look at the information that I know. I know the angle, okay, that's good. But this time, I only know the hypotenuse. I don't know the other side length, right? That's the problem, I suppose. Now, which one would you like to solve for first, I guess is your next question. Would you like to solve for the adjacent or would you like to solve for the opposite side? Okay, that's fine. It doesn't matter. Doesn't matter. So, if we want to solve for the opposite side length, then what am I going to use? I'm going to use hypotenuse, and I know I'm going to have to use opposite. So let's go find in our little acronym thing here which ones use opposite and hypotenuse. So, sine, right? So I'm going to say, okay, sine theta, or sine x, sine theta is equal to opposite over hypotenuse. Let's fill in the information that I know. I know the angle is 38. Let's fill that in. Sine 38 is equal to, I don't know opposite. What is opposite though? Z divided by, what's hypotenuse? 20. Okay. Your job here is to get Z by itself. How am I going to do that? It looks like a tricky question, but it's really not. How do I get Z by itself? Retta?
You divide both, or sorry, multiply both sides by 20.
If I multiply both sides by 20, the 20s are going to cancel. And all of a sudden, Z's sitting there all by itself, ready to be solved for. Right? So we get Z is equal to 20 sine 38. That's good. It's good for me because I know what to do next. Not good for you because it just looks like something ugly. Here's what's wonderful about this. Yes, Coco?
So is sine, like, what is it? What is it? Is it like, it's not a variable, right? Like, what?
You can treat this whole thing as kind of like a variable. You can treat the whole thing like a variable. Sign it. What you're going to find here is this whole piece is a number. I'm going to show you what number it is in a second. Okay, it's a variable. That whole piece is a variable or it's a number, depending on what you plug into it. It's a function, which you'll come to learn later. But every time, like any other function that we've done, whether it's a line or a quadratic, anytime I input something into a function, I get something out. What I'm about to write down is the something out piece, the number you get after you input 38 into this function. Okay? So, here's the catch. This is what's cool about this table. What I want you guys to go do is go find the sign column. It should be the first one. Okay? And then you go, okay, what angle did I need? 38? Okay, that's fine. Let's go find 38 in the degree column. Right there. And you read across until you hit the decimal value underneath the sign column. What's the decimal number? 0.6157. That's that whole piece. So Z is equal to 20 multiplied by 0. What was it? Sorry, Redis? 0.6157. All right. Now you just do the multiplication on that. What's your final answer? 12.31.
4.
Centimeters. Okay, we can draw that in there. Oh, we didn't find X, we found Z. Now, are you going to do that whole process again to find X? What are you going to choose? Pythagorean theorem. But be careful, because if you made a mistake finding that number, the next number is going to be wrong. You know what I mean? If you follow the same process, but this time instead choose adjacent instead of opposite, you could do the same process and know that your likelihood of being right is a little bit higher because you've used the question, you've used the information from the question. I'm not saying one is better than the, well, I'm saying one's better than the other, but I'm saying in terms of an accuracy standpoint, chances are that the more of these you do, the chances of this number being wrong, smaller and smaller the more that you do. So it's probably fine to use x squared plus y squared, or sorry, not x squared, a squared plus b squared equals c squared is okay to use. Okay? Just know as you go forward, like if you made a mistake, that mistake's gonna percolate through the question. Okay? But chances are that if you do 100 of these questions, like it's not, you're not gonna make that error. That question, this number is gonna be right the more of these you do. It's not a crazy process. Okay? So let's do that. What number is going in for what? What's C? 20. Okay. C is always the big one. So I get 20 squared. What goes on the left side? Yeah. I mean, you could plug in whatever you want, right? I could say 12.31 squared plus b squared, or in this case, b is gonna be x, right? You're just gonna solve for x. How do you solve for x? Well, I'm gonna subtract this piece from both sides, right? Or you give me a number first. What's 12.31 squared? 150? Oh, good, eh? Look at close today. 151 right on?
0.6.
Okay. Plus x squared is equal to, what's 20 squared? That's gonna be 400. So 400.
20 squared.
Yeah.
Yeah.
I'm just making sure. How do you solve for x? Subtract 151.6 from both sides. X squared is equal to, what's that number? 400 minus 151.6.
248.4.
Okay, square root both sides. What's x equal to?
A number.
13.7.
13.7?
15.
15.7, good. Should this number ever be bigger than this one? No. If it is, go check it, because it's wrong. 20 has to be the biggest number you see on your page. For side lengths, anyway. Okay?